Okay, problem 6 in the McMurray book, we've got a question asking us about the relative reactivity here. And there's a mix match of things. We have different leaving groups, bromine, tosylate, chlorine, and then we have a combination of substrates. Okay, so you want to look at the relative reactivity of your leaving groups. And remember that the order goes like this. Okay, so chloride is not as good a leaving group as bromide, is not as good a leaving group as iodide, and is not as good a leaving group as tosylate. And tosylate is abbreviated TOSO negative in the McMurray textbook. So when we draw these structures, we want to analyze carefully the whether we have primary, secondary, and things like that, okay? And we're talking about an SN2 reaction, so keep that in mind as we look at these molecules. Okay, so that's one thing to think about is the leaving group ability. The second thing to think about is the type of substrate, okay, RX for short. And remember that methyl is a better substrate than primary, better substrate than secondary, and tertiary substrates, pretty much don't even react in SN2. So let's now categorize these that we've arranged these and we're thinking about the trends, okay? So first we want to look for primary substrates. Okay, these two are primary, but are they going to tie? No, because we've just discussed how tosylate is a better leaving group than bromide. So the CH3OTOS is going to be the most reactive, followed by CH3Br. These are both methyl substrates. Now we have these two here. They're both chlorides. They're both chlorines that are going to be the leaving group as chloride. And so we need to analyze this one here is the carbon that's connected to 3, so it's tertiary, and this carbon is connected to 2, which is secondary. So remember again, secondary alkyl halides react best or better. And finally, the loser here is that tertiary alkyl halide. And this is the trend that you would expect for an SN2 reaction dominated by sterics. Thanks for watching.